So in last class, we were studying that what are magnetic field lines. So we were studying about this thing, that what is magnetic field line, and in this case we were studying about magnets. Okay, this is a magnet and this is south and north pole, and we studied that how we use compass. So we just put compass here at this side, and we will found that the needle of compass which is having north pole. Okay, so it is having north pole, will move towards south pole. So we just side by side we also draw dots. Okay, so here I'm just drawing my compass, and compass needle is showing, this is showing north pole, and we can make dot as a south pole, and we will make two dots. Okay, one is for north and one is for south. Okay, now I will pick this compass from here. Okay, and I will put this compass here. I will replace this compass here, but I will replace this compass in such a manner that this north pole will coincide or keep the direction of south pole. So I'm just picking this compass. Okay, same compass, and I'm putting this compass here. So I'm putting this compass here, so the north pole should coincide, or north pole should show the direction of south pole. Okay, so this is north pole and this is again south pole. Again I will draw two dots, one in the direction of needle which is showing by north pole, and one which is in the direction of north pole. So for north pole I'm using arrow, so it is north pole, and dot is for south pole. Okay, again I will put this compass, and I will pick this compass, and I will place this compass here in such a manner that this will show the north pole will coincide the direction of south pole, and definitely here is south pole. So here we are just drawing, here we are replacing compass, and here we are drawing the dots. Okay, so we are drawing the dots like this. Okay, so continuously we are doing this, we are picking compass and we are placing it. Again we will pick compass from here, and we will pick this compass and we will put this compass here. So in such a manner, so what happened is we will try to put north pole here, and we will try to put south pole here, but the north pole, the needle of north pole, the needle of the compass, we know that what is compass, we studied about compass, that it is a free needle, it is, this needle is free. Okay, this needle is free, so this needle will show always a direction like this. So this needle is free. Okay, so we are continuously doing this, and in this continuation we will see that this will show north pole and this dot will show south pole. This will, we are just placing compass here, and why this we can say why this thing is originated, or we can say why this curve is originated. This curve is originated because as we are picking compass from this side and we are placing compass from this side. Okay, so what I'm doing that I'm placing the north pole of the needle, okay, at the side of south pole, or just near the south pole. I just, you have to put this now north pole just before south pole. Okay, after south pole, sorry. Look like this, it is they are dot. Okay, and I want to, this is a dot. Okay, and I want to put my compass. So where should I put my compass? I will put my compass here. I will put my compass here. So north pole will be here and south pole will be here. So I am just I'm just putting my compass in such a manner. Okay, this is now my north pole, and this is my south pole. Okay, now we are putting compass. Now I want to put my compass again. So what will I do? I will put my compass. So it was north pole and it was south pole. Okay, so I will put my compass again. If I want to put my compass over this thing, okay, I will put my compass like this. I will put my compass over this. Okay, so it will show north pole. Again north pole will shift to here, it will show this direction, and south pole will come here. So we are just putting compass and we are just making dots. Okay, okay, tell me in chat box if you are okay with this thing. Do you understand what I am telling you? We are putting compass like this. Okay, just pick compass and put in direct. Pick compass and put here. Okay, so pick compass. So it we are just changing the compass and we are making a direction. So what is we are just making a point. So it was north and it was south. Okay, now what, it was north, okay, and it was south. Okay, now I will put my compass in this thing over this thing. I will put this compass over this thing. This is how we are changing. Razan beta, you are late today. Why not will north will change its direction? Yes, north will not change its direction anyhow. North will never change its direction, and I will tell you why it is not changing its direction. Okay, so I'm just, what I'm doing, I'm just picking my compass. Just this is how, just you have to pick compass from here to pick, put here, here. Okay, just pick same compass and put like this. So why this direction come, this direction is come because s, this was n and this was s. Okay, now this was a compass. Okay, now pick this compass and put here, put north pole here. Okay, put north pole near just near to south pole. Okay, just near to south pole. You don't take, you can't take this compass and you cannot put this and everywhere. Just put this compass just near to previous south pole, so the needle of the north pole will always show you a direction. Okay, now I'm picking this. Okay, now I'm picking this compass and I'm picking this compass and I'm placing this compass here. Okay, now you cannot do this, you just pick the compass and you will place this here or you place this here. No, you cannot go for this. You, one thing you need to remember, that pick compass and put north pole near south pole. Just they should not um, far apart. Okay, so the north pole will, the needle will show you this direction, and south pole. Just put this and put again this compass. You know how I am changing the positions of compass, and you can also see the changed position of the needles. Okay, you can also see the change position of needles. So here I am putting north pole here and south pole here. Definitely south pole will come here, and the direction of this needle will here. Okay, so as soon as I'm continuously doing this, the needle will show. I'm just keeping compass from changing from here. Now I want to put compass here. What will I do? I will put compass here. I will put, so the direction of north pole will here and the direction of south is here. Okay, so I just want to count, or I, my intention is to find or to follow this arrow. Okay, my intention is just to follow this arrow which is produced by this north pole. And what are we studying? We are studying the direction of this north pole. Okay, so this north pole will like this. Okay, and again I want to put compass. What will I do? I will put compass here and I will put my north pole here and south pole here. It will, the compass of the needle of the compass is free entity. Remember one thing, it is free thing. Okay, you don't need to move this needle. It will move by its direction or by its corresponding pole. This needle will move by its own. You don't need to move this needle, that I'm doing nothing. I'm just replacing the positions of compass. Only I'm doing one thing, that I'm placing this compass near to this point, and I'm not here or not here. I'm just doing one thing, that put this compass near to this point. Okay, now we have 2 points, so the needle will show like this direction. So I'm removing the compass, I'm just showing you the direction. Okay, so here again the compass will show one thing, it will show here north pole, and it will show here south pole. Now my duty is to place the this compass. If I want to place this compass, I will place this compass just near that the north pole. What is the north pole? This is the north pole, this is the north pole, we know about this, and this is the south pole. So I'm just doing one thing, I'm just placing compass in such a direction. So again north pole will show this direction, sorry, it is north pole. North pole will show this direction and south pole will show this direction. Okay, so I'm removing this because my need is to just, I want to show you direction. So this will be north and this will be south. Okay, so the direction, whole direction, you can see it was this north pole. Okay, direction of north pole, how this is how it came. Okay, so the direction of north pole is not changing, the needle is always deflecting to this side. You, some of you, one of you asked this question to me. Okay, and this is how I'm moving the position of compass. Now at this side, remember, at this side, this is our north pole. Definitely the north pole is attracted towards south pole. Okay, in our earth, this is our earth and this is our compass. I told you about this thing, okay, this needle, and I told you about this compass. Okay, so this is our earth. Okay, and this is our compass. Okay, so this is, and this thing. Okay, so this is south pole, sorry, no, north pole of compass, and this is south pole of compass. Okay, so in this thing, or in this phase, suppose this is our earth, this is our earth, and it is not, I didn't draw it in a good shape. So this is our earth. Okay, this is our earth. So earth has also its polarity. Okay, one pole is known as south pole and one pole is known as north pole. This one pole is south pole and one pole is north pole. Okay, so I told you that this needle is always towards, this needle is north pole, this needle is north. Okay, so this needle is always get attracted to south pole of earth, because this is north pole, this pole is north pole. Okay, so the south pole, this needle will always, the north pole of the needle will always toward the south pole, and the south pole of needle is always toward the north pole. Because you, one thing we studied na, that same thing repel, same thing repel, you can see how the forces dragging them apart, and in this case, you know, different poles attract and different poles attract, so you can see how the poles are attracting each other. Same thing is getting here. In this case, this north pole is deflected toward, no, it is not necessary that north pole should be up and this and that. Okay, because it is the people, those who are sitting right at south pole, they think south pole is upwards. Okay, so don't get confused about it, that north pole should be up and south pole should be down. That is not the reason. Okay, so, or if you want to make me to do this, I don't have any problem while doing this, north and this is south. Okay, but don't you know, it is a very kiddish thing, that if you think that it should be up and it should be down. Okay, happy? So this is now my south pole and this is my north pole. Okay, so earth, the north, the thing which is showing you north in this compass. Okay, actually this north pole is getting attracted toward the south pole of earth. So actually the north pole of this, the north pole of this is showing you the south pole of earth, because it is getting attracted, because different poles attract. Okay, and this is actually south pole which is showing you the north pole of earth. Okay, So this is how this compass works. Okay, so we have opposite polarity from compass to this. Okay, it doesn't mean that it is showing you north pole, it means that it is showing north pole of earth. Definitely no, if it is north pole, definitely it is getting attracted to the south pole of the earth. Okay, and one thing I want to tell you, beta, about your doubt. You told me that south pole should come down and north pole should up. Okay, you told me that this should be north pole and this should be south pole. Okay, this is definitely not good to make you understand. If I draw this, I'm drawing the circuit. Okay, I'm drawing the circuit. Okay, this is my circuit. Okay, and this is plus terminal and this is minus terminal. Okay, so plus terminal is south pole and minus terminal is north pole. We considered like this. Okay, so this is how our electricity conduct from positive to negative. Okay, if I draw this, if I want to draw this, now this is negative pole and this is south pole. So it negative pole is considered as north pole and this is considered as south pole. So the electricity flow, direction of electricity will be like this. Okay, so don't get confused. Just we are going to we will just be focus on the direction of needle, and what is the direction of needle tells us the direction or the polarity of it can also help us to find the poles of magnet. If it is a raw magnet and it is just collected from somewhere and we don't know what is the pole, this is a pole and we don't know that what is the pole, this is a raw magnet. So this will help us to identify. So if this thing will always show that is it, that it is getting attracted to south pole. Okay, so this is our how our question comes. Okay, so you know that in this compass north pole is always getting attracted to south pole. Okay, so still from this, in this whole thing you will know that this north pole of this compass, because we are doing something with compass. Okay, we are just changing the position of compass and the direction or the needle of compass is always in this direction, because this north pole of compass will always get attracted toward the south pole still here. Okay, it will not change direction because it wants to go to south pole because it is north pole, and it will the deflect. I'm just showing you the direction that how the this line will arise. The my main focus is to show you that how this thing arise. Okay, this thing arise. We are just doing one thing. We are getting a 2 points. We are getting 2 points and just putting the next step near this thing, and the direction of uh, north pole, the needle will show exact this direction. Okay, it will show this parabola, this half circle thing. Okay, half circle thing. Okay, it will not show the direction of like this, or it will not show direction like this. It will not show, it will just show this direction. It will show us this direction, which is half circle. Okay, and this is this line. Okay, if you start this from here, you can also start from this here, so it will show this direction. Yeah, basically no, needle is indicating different pole. Okay, Faizan beta, are you done with this, or is this thing okay for you that actually it is indicating pole? This needle is this needle. Okay, this north needle is indicating you that it is towards the south pole of some object. Either you can use it for earth, okay, or you can use it for magnet, or you can use it for anything. This north needle will show you that it is getting attracted to south pole of some else thing. Okay, if you are using this on earth, you just place it, so this north pole will show that this is the south pole of this earth. Okay, that's why this north part is getting attracted towards south pole, and this south pole will tell you that this is the north part of earth because it is getting attracted toward the north part of the earth. Okay, and if you use this, if you use this for this type of magnet, definitely they will show same thing. North will always get attracted towards south pole and south will get attracted towards north point. This was my basic agenda to make you understand that this is very new, nothing new for you, you just know about this. But north attracted towards south and south attracted towards north. So if you can draw this also, and if you start from this, then the paths will be like this. Sorry, I make it wrong. It will be like this. Okay, same thing I'm doing, I'm placing the uh, it will be like this. Okay, and here it will be like this, and here it will be like this. Okay, so here the direction of compass is here, the direction of north pole will be here, and here the direction of north pole will be here, because the north pole of compass is indicating the south pole, and it wants to get attracted towards south point, or it will get attracted toward the south point till the end. So it will be showing its needle in this direction. Okay, in this direction. Okay, Faizan beta, is it clear to you? Am I clear to you? Concept is clear to you, or something is making doubt? Clear. Okay, so nothing is doubtful for you, Salia, tell me. If anything is doubtful for you, you can just do this same thing. Do this same thing, put this compass. Okay, put this compass and do this for here. Okay, so just my main concern is I want to tell you two things. Okay, I want to tell you two things. First of all, I want to tell you about the direction. First of all, I want to tell you about the direction, that the direction which is followed by the north pole is still this. Okay, and if I'm doing this from here to here, the direction of my compass needle, which is north pole, is showing this here. So the direction is still here. Okay, we are just making dots and we are doing this, that's one thing we are doing. Okay, we're just making dots. Okay, so in this case, just consider that shape, just consider the shape, the half circle we obtained. Okay, the half circle we obtained. So if I want to improve my diagram, or I want to increase something, I want to improve my diagram, so I'm improving my diagram. I'm improve my diagram like this. One circle from here and one circle from here. Okay, just one compass round. Okay, this is one compass round. Now I want to make another compass round. I will do this, and I will do this. Now I want to make my third compass round. Okay, I'm putting third compass round, and direction will be like this always. Okay, I did my third compass round. This is third compass round. Okay, you can make so many compass round. You can use one compass round, you can use second compass round, you can use third compass round. How many rounds you want to make? Okay, so this is my compass rounds. Now one thing is very clear to you. Okay, I can make so many compass rounds. Okay, and I can make so many compass rounds. Okay, so direction will, don't forget about this direction, don't forget that compass needle, we are making these rounds by our compass, and the direction will be always in this direction. So don't forget that why I'm putting arrow like this. Don't forget this, it will helps you a lot, it will helps you a lot. This thing I made wrong direction, I made wrong direction. Okay, just do this. Okay, till the end, till the end, because we studied what happened really exactly. Okay, now you can observe something, or you can see something. Okay, that from here we can see, if I draw this huge round, okay, if I draw this huge round, it will be like this. Okay, so these lines are known as magnetic field lines. Magnetic field lines. Okay, what are magnetic field lines? That this is a magnet. Okay, This is our magnet and it will attract iron. Okay, so it will attract iron definitely. But how and in which manner it attract iron? We studied about this experiment, that if I put this iron and on a cardboard, this is my cardboard, and I put this magnet, sorry, this magnet over this cardboard, and I sprinkle some iron flakes near it, and just shake this cardboard a bit. Okay, so these iron flakes will acquire shape of this, okay, you can see the shape of this. Okay, and same time you can see a much amount of aggregated iron at these poles. Okay, at these poles. Okay, same thing, that we are using magnetic field, we are going to we studied about magnetic field lines, that this iron has a sorry, this magnet has a field. Okay, it has a power, this magnet has a power to attract iron, or our earth has magnetic field line in such a manner like this. Okay, so magnetic field lines, if this I draw a magnetic field lines are not present in this shape, or magnetic field lines are not present in this shape. Okay, this is magnet. Okay, or magnetic field lines are not present in this shape, though magnetic field lines are present in this particular shape, which is half circle shape. Okay, it is present in this shape because this particular shape, as our uh, compass indicated us, that it will show the path like this. It will definitely, the we are following the direction of this needle, and it will give us this dot structure. It will give us a structure of this dot. Okay, that's how we can say that the magnetic field lines we are getting is present in half shape or half circle shape. This is okay, so this is magnetic field line. So this magnet will attract iron or anything else, but like this, there is no another shape which is present. This is also this shape, we can say this is a shape, and this is our earth has also having this magnetic field lines, because earth is also having north pole and south pole. So each and everything which is having two poles, north or south pole, it behaves like magnet. We studied in our previous classes that something we studied this, that they also show poles. Okay, something shows south pole and north pole, positive and negative also shows pole. So this is magnetic field lines, and it is present like this in bar magnet. So this is a particular shape of magnet. First thing. Second thing is, first let me tell you what is magnetic field lines. Magnetic field lines, particular shape, and one most important thing I want to tell you. Yeah, look at here. This is the needle of compass. Okay, you can observe the needle of compass here, 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 and here. You can see. Okay, you can also repeat this with this thing. Okay, so this is how the needle of the compass reflects, and this needle shows south pole. Okay, just remember that if you are not given something which color, then you have to remember that this is the needle. Okay, and it will show north pole. Okay, so this is north pole, and it is getting attracted towards south pole. Okay, in another diagram same thing is here. So this is north pole, and it is getting attracted towards south pole. So this is magnetic field lines, and you can see the particular shape. Okay, it is, you can see, approximately a half circle. Okay, so we have drawn magnetic field lines. You can draw so many. Okay, So the space around a space around a magnet, this is a magnet, and a space around the magnet in which the force of attraction and repulsion due to magnet can be detected is called magnetic field. Okay, magnetic field means this magnet will feel at this magnet will definitely attract something, another magnet, or it will uh, repel something depending upon which pole is present. Okay, this is north pole and this is south pole, definitely they will get attracted. Okay, but both of them will get attracted only when they are close this much. If I'm placing this magnet here and if I'm placing this magnet here, okay, or if I'm placing some magnet here facing, two poles are same and two poles are different, definitely at this distance they will not face anything of like attraction and anything of like repulsion. But at this distance both of them will feel something and both of them will attract something or repel something, definitely. Okay, so the magnetic field is an area or a zone or something, some power which is present outside a magnet so that it can feel something to attract or it can repulse something. So it is having a zone. Okay, and if you put something far apart, definitely both of them are not going to feel something. So just you have to place them in their magnetic fields. To you have to make them close enough to that they can feel their magnetic fields. Okay, I'm giving you a very interesting example that this is our earth. Okay, this is our earth. Okay, and this is its magnetic pole, magnetic field line. Okay, and this is its pole, it is north pole and it is south pole. Okay, now definitely our earth is having its magnetic field. Okay, and any sometimes asteroids and meteoroids pass by this. Okay, some asteroids and meteoroids, they are also having their magnetic fields. These asteroids and meteoroids also having their magnetic fields. So there are two chances. Sometime you hear that asteroid get attracted by earth and this asteroid will uh, came to earth and it will struck to earth. Okay, so in this case they both of them get attract. Okay, but in another case when the asteroid or meteoroid is much far, okay, that when the both magnetic fields are close enough so they can feel attraction or definitely they can feel repulsion, definitely. So it will get attracted or it will get repulsed, what is the polarity it is facing. Okay, but if the meteoroid is much far that neither it is feeling any type of attraction or nor it is feeling any type of repulsion because it is far apart. Okay, so this meteoroid cannot be get attracted by our earth. But this meteoroid which is very much close enough, and if there is different polarity, now we are not going to make understand that what is polarity of this meteoroid and what is the polarity of this earth. You will get understand in another topics of same chapter. So like this, I'm just giving you idea. Okay, this is south pole of this meteoroid and this is north pole of our earth, and if they get attract, definitely it will come to earth and struck the earth. Okay, and sometime it get repelled, definitely. So this is when two magnetic field, each and every magnet is having its magnetic field, each and every magnet is having its magnetic field, even though humans are also having our magnetic fields. Okay, so to this magnetic field, you can say it is an area or you can say it is a zone. Okay, it is something which makes this magnet or this bipolar thing to attract something, to feel it that I have to attract something or I have to repel something. So it should come in this particular area. Otherwise two separate magnets which are one is placing in this classroom and one is placing in that another classroom, they cannot repel each other and they cannot attract each other. But definitely they show the zone in which they show attraction or they are much powerful and they attract something only or they repel something only when another thing come into these particular lines, and these particular lines are known as magnetic field lines, which we have drawn, that how this magnet will attract something or how this magnet will repel something. So this is a zone which is known as magnetic field, definitely. But this magnetic field is present in form of lines. Okay, this magnetic field present in form of lines. Okay, it is it is an area or portion or zone in which this magnet can attract something or repel something. But the magnetic field is present in the form of lines, and this is known as magnetic field lines. So this is we studied about magnetic field lines today. Okay, now I'm going to start another topic. This is okay. So this is magnetic field line. Now you can see two more things. Okay, so magnetic field lines, curved path. This is curved path or curved lines. Okay, so magnetic field in shape of lines, curved lines, you can say magnetic field lines. Okay, now I'm going to give you an idea, or I want to tell you something which is very interesting though. Look at this. Okay, here you can find, this is magnetic lines, you can find the direction. So first thing you can find that at this side and at this side or pole, okay, the number of magnetic lines or the concentration of magnetic lines is huge rather than any other area. In this particular area, the concentration of magnetic field lines, you can see it is huge. Can you see this? And if I consider this, okay, or if I consider this, okay, so we can find the high number of magnetic field lines near poles. You can see the amount. Okay, so definitely the concentration, because most of them, okay, why this is so, all of them are originating from this same point. This is the reason they are originating from, so many magnetic field lines can create. Okay, they are originating from this point, but when they go here, they will get separated or they will get apart. When they go like this, they will get separate or they will get apart. They are getting separate, okay, or they are getting apart. You can see they are getting apart. But here they are originating from same point. So here they have a scope to get apart. They have a scope to get apart. They have a scope to get apart. Okay, and definitely they are getting apart. But here, okay, they have only this much area. So from this much area, so many magnetic field lines can originate. So this area of poles, either south pole or either north pole, both of them having very high concentration of magnetic field lines, because here they cannot get apart. They have to originate from same point. They have to originate from same or single point. Okay, what is magnetic field line? Magnetic field line is magnetic area. Definitely magnetic field, but in form of these semicircular lines, in form of semicircular lines. These are magnetic lines and they are originating from same point. So definitely they need to be much concentrated here, and they are very, lighter when they get apart or they get separated. So this is the most important property of magnetic field lines. Now I'm going to just revise you this thing. I will take you 2 minutes and after that I will finish my class. So properties of magnetic field lines. First, magnetic field lines is directed from north pole to south pole. From north pole to south pole. Come, how they originated? We did this experiment. They originate from south pole. And they end to north pole, isn't it? So originate from south pole. Whatever you're taking, if you are taking this part, or if you are taking this part, they originate from south pole and they end to north pole outside. Okay, and if I continue this, so this will, I'm completing the circle. You can see like this, or you can see we studied. And if I want to make a circle complete, what will I do? This is how I can make my circle complete. Okay, this is how I can make my circle complete. So these magnetic field lines these magnetic field lines originate from south and ends at north outside. Okay, but if I want to fulfill my circuit, or if I want to complete my circuit, just I can do this in same direction. Okay, I'm not changing my direction. I'm not changing my direction. This is the direction. I'm not changing my direction. Look. Okay, so this is how I will explain this on you on tomorrow, because time is running out. Actually, it is run out. So I will tell you this rest of the thing on tomorrow same time. Okay, so please revise this. This is just from your NCRT. Okay, I just explained you. So next class will be on tomorrow.